Every AI app you've ever used that actually knows your data, your documents, your emails, your code base, uses one technique behind the scenes. It's called RAG, Retrieval Augmented Generation. And in the next 15 minutes, you'll understand it better than 90% of developers. From the ground up, no fluff. Let's go. First, the problem RAG solves. Large language models like GPT and Claude are trained on a snapshot of the internet. That snapshot has a cutoff date. Anything after that date, they don't know. Your company's internal documents, they don't know. Your customer database, they don't know. Your product documentation that was updated yesterday, they don't know. You can paste context into the prompt, but that only works for small amounts of data. What if you have 10,000 documents? A million rows in a database? You can't paste all of that. RAG is the solution. It lets the model retrieve the right information at the right time automatically, so it can give you accurate answers from your data. Here's the simplest way to understand RAG. Imagine you're taking an open book exam. The exam is the user's question. Your brain is the language model. It knows general things but not everything. The textbook is your company's data. Without RAG, you're taking the exam with your book closed. You answer from memory. Sometimes you're right, sometimes you hallucinate. With RAG, you're taking the exam with the book open. Before answering, you flip to the relevant page, read the exact passage, and then answer. That's it. RAG is the process of opening the book to the right page before answering. The architecture has two phases. Phase 1, index time. This happens once before any user asks a question. You take your documents, PDFs, web pages, database records, whatever, and break them into chunks, usually a few hundred words each. Then you convert each chunk into a vector, a list of numbers that captures the meaning of that text. These vectors go into a vector database. Pinecone, Chroma, VV8, Quadrant. These are all vector databases. Think of it as building a library where every book is organized by meaning, not by title. Phase 2, query time. A user asks a question. You convert the question into a vector. Then you search your vector database for the chunks that are closest in meaning. The top 3 to 5 most relevant chunks get added to the prompt alongside the user's question. The model reads both the question and the relevant context and generates an answer that's grounded in your actual data. That's the entire architecture. Let me break down each component. The document loader reads your data. It could be a PDF parser, a web scraper, a database connector, or an API call. LangChain alone has over 100 document loaders for different data sources. The chunker splits documents into digestible pieces. Too big, and the model gets confused. Too small, and you lose context. The sweet spot is usually 200 to 500 words with some overlap between chunks. So important sentences that span two chunks don't get cut in half. The embedding model converts text into vectors. OpenAI's ADA model, Cohere's embed, or open source models like sentence transformers all do this. The vector database stores and searches these vectors. When a query comes in, it finds the nearest neighbors, the chunks whose meaning is closest to the question. The retriever orchestrates the search. It might use simple similarity search or hybrid search, combining keyword matching with semantic search for better results. And finally, the generator, the language model itself, takes the retrieved context plus the original question and produces the answer. Let me show you what a basic RAG pipeline looks like in code. Step 1. Load your documents. One line. Point it at a folder of PDFs. Step 2. Split into chunks. Set your chunk size and overlap. Two lines. Step 3. Create embeddings and store in a vector database. Three lines. Step 4. Create a retriever. One line. Step 5. Chain the retriever with the language model. Two lines. That's it. 10 lines of code for a working RAG system. You ask a question, it searches your documents, finds the relevant chunks, and gives you an answer with the source cited. Obviously, production systems are more complex, but the core is genuinely this simple. Now let's talk about what separates basic RAG from production RAG. Hybrid search. Instead of just semantic search, combine it with keyword search, BM25 plus dense vectors. This catches cases where semantic similarity misses exact matches. Re-ranking. After retrieving 20 candidates, use a cross-encoder model to re-rank them by relevance. This consistently improves accuracy by 15 to 30%. Query transformation. Before searching, rewrite the user's question to be more search-friendly. What's the return policy? Becomes return policy terms, conditions refund deadline. Metadata filtering. Tag your chunks with metadata. Department, date, author, document type, and filter before searching. Show me the Q3 sales data. Should only search finance documents from Q3. And multi-step retrieval. For complex questions, break them into sub-questions. Retrieve separately, then combine the results. This is how agents use RAG, iteratively retrieving until they have enough context to answer. 5 mistakes that kill RAG systems. Mistake 1. Chunks, too big or too small. Too big and irrelevant noise drowns the answer. Too small and you lose context. Test different sizes. Mistake 2. No overlap between chunks. Important sentences get cut in half. Always use 10 to 20% overlap. Mistake 3. Not cleaning your data. Garbage in, garbage out. Strip headers, footers, page numbers, and formatting artifacts before indexing. Mistake 4. Using only semantic search. Keyword search catches exact terms that embedding models sometimes miss. Always use hybrid. Mistake 5. Not evaluating. You build it, it seems to work, you ship it. Then users report wrong answers and you have no idea which retrieval step failed. Add evaluation from day one. Measure retrieval precision, answer accuracy, and hallucination rate. Where is RAG used in the real world? Customer support chatbots that answer questions from your knowledge base instead of making things up. Internal search across thousands of company documents. Find the right policy, contract, or specification instantly. Code assistants that understand your code base, not just generic programming knowledge. Legal research tools that search case law and regulations. Medical assistants that reference clinical guidelines and drug databases. Financial analysis tools that query earnings reports and filings. And every AI agent that needs to remember things across sessions. RAG is the memory layer. The market for RAG tooling is projected at $4.18 billion in 2026. It's not a niche technique. It's the backbone of every serious AI application. The tools you need to build RAG in 2026. For frameworks, LangChain and LlamaIndex are the two standards. LangChain for flexible pipelines. LlamaIndex for document-heavy applications. For vector databases. Pinecone for managed cloud. Chroma for open source local. VV8 for hybrid search built-in. Qdrant for performance at scale. For embedding models, OpenAI's text embedding 3 for quality, Cohere embed for multilingual, and sentence transformers for free open source. For evaluation, Ragus is the standard. It measures retrieval precision, answer faithfulness, and context relevance automatically. And for production, LangSmith for tracing and debugging your RAG pipeline end to end. That's RAG, Retrieval Augmented Generation, the technique that makes AI actually useful with your data. Open book exam, not closed book guessing. If you want to go deeper, I've linked every tool and framework mentioned in this video in the description. And if you're building AI applications, check out our guides, Claude Code, Codex CLI, and the AI Agent Roadmap. Links below. Drop a comment telling me what would you build with RAG. Subscribe. More deep dives coming. See you in the next one.